Okay, I'll show you what's the magnetic field at a point on the axis of circular coil carrying current. Let's use Biot-Savart's law for that. So I have a circular coil carrying current. Let I be the current, and we are looking at the coil from sideways, so radius of the coil be r. The coil is in YZ plane, so the axis of the coil is like this, probably along x direction you can take. Let's mark a point here. Today we are interested in finding what is the magnetic field at this point. Let's say this point is at a distance x from the center of the coil. Now see, I want to use Biot-Savart's law. Biot-Savart's law is applicable for a current element, so I need to mark a current element, small current element dl. Now what's the radius vector to the point? Say this point is at a distance r from this current element. Now remember, coil is in YZ plane. How do you draw the radius vector? First you have to imagine a tangent to the current element, and radius vector is a perpendicular distance of the point from the current element. So obviously, okay, the angle between the radius vector and tangent to the current element is 90 degree. I know my Biot-Savart's law, mu naught by 4 pi current, length of current element, sine of the angle between the radius vector and the current element by distance square. Remember, the direction of this field is perpendicular to the plane formed by the current element and the radius vector. Okay, so I will write, say it is perpendicular dB. Okay, so this is my magnetic field. Suppose this makes an angle phi, then this makes an angle phi here. Okay, now magnetic field at this point is not only due to one current element, right? There are innumerable current elements along the coil, along the circumference of the coil. So there will be several of these dBs. Okay, now for every magnetic field produced by current element, there is always another current element, beautiful, another current element somewhere, so that, okay, so that the magnetic field is exactly as dB but in the opposite direction, right? So that a component of the field formed by one current element is cancelled by the component of the field formed by another current element which is exactly opposite to it. Similarly, if current element here, okay, will have another counterpart which cancels out a component of dB. Now if you resolve this, so this will be cos component dB cos phi, and this will be sine component dB sine phi. So here, if you resolve this, again this will be the cos component dB cos phi, and this will be the sine component dB sine phi. What is happening? If you take such pairs along the circumference, innumerable current elements along circumference, cos components of magnetic field cancels out and sine components will add up. Therefore, B is integral of all such magnetic field but only sine component of those magnetic fields. So dB sine phi. Now I know from Biot-Savart's law, I know what is dB. dB is mu naught by 4 pi IDL sine theta by r square. Now theta equal to 90 degree. So dB is essentially mu naught by 4 pi IDL by r square. Now what is this distance? See, the distance we can write in terms of radius and the distance. So I know this Pythagoras theorem, r square plus x square. Okay, so I'm going to write it here. So B is dB is mu naught by 4 pi IDL by r square. Correct? Where is sine phi? This one. Okay, sine phi. Now mu naught by 4 pi IDL by r square. What is sine phi? This is phi, so phi is opposite by hypotenuse, so it is opposite is r by small r. Okay, so let's integrate. Mu naught by 4 pi constant, current is constant, right? So r square by small r, so let's write this as r cube. Okay, and r is also constant, so I'm left with dl. If you integrate all the current elements, what do you get? Ultimately you get the circumference of the coil. So I can write mu naught by 4 pi I r small r cube. Okay, integral of dl is nothing but circumference. Circumference is nothing but 2 pi r. Okay, so it is mu naught by 4 pi I r square. Okay, I can do one thing twice. So I'll write it as mu naught by 2 I r square divided by r cube. I know what is r. R is under root r square plus x square, so it is r square plus x square whole to the power of 3 by 2. Okay. B. So this is the magnetic field at this point. Now if you want what is magnetic field at the center of the coil, see, for the center of the coil, you can use directly Biot-Savart's law and integrate over the length. From this formula also you can get the same thing by considering the distance of the point from the axis, from the center is 0. If x equal to 0, what do you get? This point comes right at the center, so we get B at the center. Okay, mu naught by 2 I r square by r square plus x square whole power 3 by 2. X square is 0, so r square whole to the power of 3 by 2, which is basically r cube. So r square and r cube will cancel. Mu naught I by 2r. If there are several turns, okay, for n number of turns, we can write B at the center is equal to mu naught by mu naught n number of turns, n I by 2r.